Assalamualaikum and good day to Dr. EZANEE. My name is Maryam binti Ahmad Ali ZUBAIR, matrix number 279208, and for Production and Operation Management Individual Assignment, I am going to present the title Servqual. Firstly, I'm going to share the definition of service quality and the definition of the Servqual model. Quality is a strategic tool to attain operational efficiency and improve business performances. However, since quality is not easily identifiable and measurable due to their inherent characteristics, the Servqual model was developed as one of the major service quality measurement skills since the 80s to evaluate the quality of services. Servqual is a gap model proposed by Parasuraman, Zaitham and Berry in 1985 and 1988. The concept of this model is a gap between the customer's expectation by the way of service quality from a class or service provider and their evaluation or perception of the performance of a particular service provider. The original formulation, which is in 1985 developed by Parasuraman, identified 10 components of service quality. Number 1 is reliability, number 2 is responsiveness, number 3 is competence, number 4 is access, number 5 is courtesy, number 6 is communication, number 7 is credibility, number 8 is security, number 9 is understanding and knowing the customers, and number 10 is tangibles. In 1988, the Servqual model was redeveloped. The components were collapsed into 5 dimensions. Number 1 is reliability, number 2 is assurance, number 3 is tangibles, number 4 is empathy, and number 5 is responsiveness. Reliability, tangibles, and responsiveness remain distinct, but the remaining 7 components were collapsed into 2 aggregate dimensions, which is assurance and empathy. Parasuraman developed 22 variables with which to measure the customer's expectations and perceptions, the E and P, of the 5 rated dimensions. And since the gap is between customers' expectations and perceptions of performance on these variables, the Servqual scale is comprised of a total of 44 items, 22 of expectations and 22 for perceptions. And this is the Servqual scale variables consist of 5 dimensions, which is reliability, assurance, tangibles, empathy, and responsiveness stands for rater. And each dimension has their own definition. Reliability defined as the ability to perform the promised service dependably and accurately. Assurance was defined as the knowledge and courtesy of employees and their ability to convey trust and confidence. Tangibles is the appearance of physical facilities, equipment, personnel, and communication materials. Empathy is the provision of caring, individualized attention to customers. And responsiveness is the willingness to help customers to provide prompt services. And the number of items in the scales, there are 4 items in reliability, 5 items in assurance, 4 items in tangibles, 5 items in empathy, and 4 items in responsiveness. And this is an example of a Servqual model or a gap model. It is called a gap model because of the gaps here, here, and here, which is a gap between expectation and perception of consumers. And this is for marketers. Now, I am going to relate the Servqual model with a topic in production and operation management subject. In POM, quality is defined as a standard of something as measured against other things of a similar or the degree of excellence of something. Statistical process control (SPC) is defined as the use of statistical techniques to control a process or production issue. SPC tools and procedures can help you to monitor process behavior, discover issues in internal system, and find solutions for production issues. Instead of the Servqual model, In POM, we are using the control chart. The control chart is a graph used to study how a process quality changes over time. Control chart has a central line for the average, an upper line for the upper control limit UCL, and the lower line for the lower control limit LCL as shown in the example below. There are two control charts for attributes, which is the P chart and the C chart. The P chart uses portion defective in a sample, while the C chart uses number of defects, non-conformities in a sample. To develop a P chart, we must find the UCL and the LCL of the chart. To find UCL, we must use the formula P bar plus sigma P. To find LCL, we must use the formula P bar minus sigma P. And to find the sigma P, we must use square root P bar in bracket 1 minus P bar divided by the sample. Z stands for the number of standard deviation from process average. P stands for the sample proportion defective or the estimates process mean. And SP stands for the standard deviation of sample proportion. This is an example of P-chart construction. I have used spreadsheet in order to create the P-chart. Firstly, I have to create a table which is consists of sample n equals to 100, defects, proportion defective, P bar, UCL, and LCL. All of this is needed in order to create the graph. Firstly, there is the sample, which consists of 10 samples. The n is equal to 100 and it is constant for all samples, makes the total is 1000. The defect is equals to 200 defects. To find the proportion defective, we must take the defect divided by the n equals to 100 and you will get 0.1. Same goes to the other proportion defective. For example, 15 defects divided by 100 equals to 0.15 proportion defective. To find the P bar, we must take the total defect 200 divided by n 1000 and you will get 0.2. To find the UCL, we must use P bar plus 3 sigma square root P bar multiply in the bracket 1 minus P bar divided by n and you will get 0.32. To find the LCL, we must use P bar minus 3 sigma square root P bar multiply by in bracket 1 minus P bar divided by n and you will get 0.08 for every sample. And this is the P chart based on the table just now. And from the P chart, I can conclude that the production must be stopped immediately and an investigation must be made on line 6, which is this one, because it is above the upper control limit line. These are the formula needed in order to create a C chart. We need UCL and LCL same with the P chart just now. To find the UCL for C chart, we need C bar plus with sigma C. To find the LCL for C chart, we need C bar minus sigma C. And sigma C is equals to square root C bar. C are the number of defects per sample. By using spreadsheet, I have constructed a table in order to construct the C chart. In the table consists of the sheet sample, number of defects, C bar, UCL, and LCL. The total number of sheets is 10 samples. The defects are 382. The sigma is 99.74, which is 3 sigma. In order to find the C bar, we must take the total number of defects divided by the total number of the t-shirt, which is 10, and we will get 38.2. In order to find the UCL, we must take C bar 38.2 plus 3 sigma square root C bar and we will get 56.74. To find the LCL, we must take C bar 38.2 minus 3 sigma and multiply by square root C bar and we will get 19.66. And this is the C chart that I got based on the table just now. And from the C chart, I can conclude that the process is out of control. Investigation must be made on line number 3, line number 5, line number 8, and line number 10 because it is above the upper control limit line, and this one is below the lower control limit line. Investigation must be made to find the causes of the defective products in these 4 lines. Based on my findings regarding the Servqual model and after relating it to a field in POM, I can conclude that quality is very important in many fields. Quality control is not limited to only businesses. Quality is measured in different fields to know a certain firm, company, or business performance. With quality models, such as the Servqual model or the control chart just now, the performance of a firm, company, or business can be evaluated. The defectives can be reduced and improvement can be made. That is all from me regarding the Servqual model and quality in production and operation management. Thank you.